two things. You have some doubt in the exam paper, right? Oh, so actually the solution that you were seeing, there were some modifications that I made while typing the paper. So you actually saw the wrong solution. So your answer is wrong. That's why I did not give you the mark. But it's not that there was you were thinking that there is a problem in your question paper, right? No, it's not like that. But if you still want to see, you can come and discuss with me, no problem. And regarding your progress of this report, the project report, okay, even if you are not able to write properly, it's okay. Ultimately, you will lose only few marks, right? But don't use unfair means, for example, ChatGPT or anything. That is my suggestion, and again, to drastically improve your quality of presentation. In long run, it will not lead you anywhere. In the last class, we started to discuss the difference between probability and statistics, right? And in today's class, we will start discussing this statistics in more detail. Random variables are represented by PDF or PMF, right? Now this much is clear so far. PDF or PMF have a shape, functional form, and parameters, mean, standard deviation, etc. Right? If, for example, let us take the example of normal distribution. What were the parameters of the normal distribution? Mu and sigma. Mu is mean, sigma is standard deviation, right? So, and it has a certain bell shape, right? And it represents a continuous random variable. So random variables are represented by PDF. So if PDF or PMF is given to you, you have all the information about the random variable, right? But who will give this information? Nobody will give. Nature does not give you this information. That's what we discussed. That's what we discussed in the last class, that nature will not give you, okay, there will be a rain which will follow a normal distribution. No. There will be a rain for which you can draw a histogram which will look like normal or may look like normal or log normal, whatever. In real life, we need the idea about the shape of the distribution. How will you get the idea about the shape of the distribution? By looking at the histogram. By looking at the histogram, you have to imagine what kind of shape is this. So this is intuitive and subjective, right? And its parameters, of course. First thing is this shape. But shape will not help you. You need to have concrete parameters. Concrete, not the concrete. Concrete means concrete. Not in literal sense, but in concrete sense. So parameters, you need to have parameters. Because once you have parameters, you have the exact mathematical equation which will define the distribution, right? Only then we can carry out the remaining analysis. We can calculate expectation. We can calculate the expectation of a function which is function of a random variable, right? And all types of analysis we can do. Therefore, we need to carry out the statistical analysis inference of the collected sample data. So how it works? Suppose you want to model the cohesion of the soil. So you went on this mountain and you collected, say, 1000 samples on the entire mountain range. And then you came back. Then you plotted a histogram. By looking at the histogram, you found a shape. And then you somehow estimated the parameters of the distribution. That's how you can characterize the cohesion of that particular site, which will follow a distribution, because it is a random variable. Why random, and what kind of randomness is there? aleatory randomness, because it is changing from point to point, which is not in your control. The thing which is not in our control is aleatory. Thing which is in our control, or which may be in our control, is epistemic. Correct? Because it is beyond our control. We cannot tell the nature, okay, you put COV of 20%, or you put COV. We cannot tell that to nature, right? So therefore we need to carry out the statistical analysis of that data, and we have to make the inferences out of it from that data. Okay, that's how we will get the information about the distribution of the parameter and the parameters of the distribution. So in real world, first we collect the data, then estimation of parameters, choice of distribution. So this part is known as statistical inference, because you can determine log normal distribution, she can determine hypergeometric distribution, let's say, or say exponential distribution. For example, one problem she solved using exponential distribution, although I gave that some hint that it is log normal, but she solved using exponential. I gave her full marks. I did not deduct the marks because it is her judgment, and which was logical, right? So that is known as statistical inference. Then calculation of probabilities. So once you have distribution, you can calculate different types of probabilities, right? What is the probability that your random variable lies between? So how will you write this probability? 1 to 2, right? As simple as that. So basically whole statistical drama is to get this function. If you have this function, then everything is in your control, frankly speaking, right? So calculation of probabilities using the prescribed distribution and the estimated parameters, and then information for decision making and design. Now what will you do with this probability? You will do the design. I want to know what is the probability that 90% of the times the load will be less than 100 Newton. Or I want to know, tell me that load which will not be exceeded more than 5% of the time. So this is again the same problem. Phi of this minus 0, right? So you can do anything, all types of probabilities, all types of design, decision makings you can make out of that. Okay, so that is basically the whole picture of this course, of this probability that I taught so far, then statistics that I taught, I'm going to teach now. So this is the entire idea. Probability gives you theory to do the maths. Statistics gives you the data on which you want to apply the maths. Okay. Now, there is a word point estimation. So this is made of two words. One is point, one is estimation. What you are going to estimate here? What you think can be estimated? Or what we want to estimate here? Parameters of the distribution. For example, in the normal distribution, what are the parameters? Mean and sigma, mu and sigma. So estimation belongs to the parameters of the distribution. And point. What is point? What is the definition of point? Correct. Dimensionless geometrical object. It means if we are going to make an estimate, we are going to say this is the estimate. Not exactly precision, but we are saying that this is a point estimate I made about entire thing. Now you don't question about that estimation. Somehow I am saying don't question about that estimation. Assume it is correct. But in reality, that point will not be a point. That point will be a circle.
Yes.
That point will be a circle with finite diameter. And that is the source of, again, epistemic uncertainty, aleatory, or some kind of uncertainty. But somewhere we have to stop, right? It is never-ending process. If uncertainty is here, then uncertainty is there, then uncertainty is there. This world created by God, then who created the God? If someone created the God, then who created that person? So it is not going to end. So we have to make some assumption and start doing the practice. Practicing engineers, right? We are not philosophers, right? We have to do the development, earn the bread, feed the family. And philosophy, good for the bedtime stories. So we have to stop somewhere. The exact value of the parameters will never be known. The best possible thing that we can do is to estimate the parameters using the available limited sample data. That's what we can do at best. Now, the notion of accuracy, exactness, you have to come out of that. Now, the notion is, what is best possible thing? What is optimum possible thing? So, there is a philosophy attached to it. Sometimes we say, sir, I will give my best. I will give my best. Okay. But you should say, I will give my optimum. So, we should not say all the best. We should say all the optimum. Is it visible or I should करना पड़ेगा ना? So this is real world population, true characteristics unknown, random variable x, inference that x is from -infinity to +infinity with a distribution fx. This is this, okay? So this is theoretical model, okay? This is coming from theory of probability. And here sampling, experimental observations, then we collected the samples and then we collected this histogram. This is coming from the applied statistics. And then we are making inference here that this shape is looking something like this, right? And then we are fitting this one. So this is statistics and this is probability. So mean mu here is when we say there are two things now. Very important thing. Most of the times people may be confused with this, but I think at least now you guys will not be confused. One thing is population, another thing is sample. Okay. P for population, P for probability, S for sample, S for statistics. Okay. Statistics talks about samples. Probability talks about population. Statistics always aspire to reach to the population. Okay. Probability is like a philosopher and statistics is like practical thing. Okay. So sample will always be based on very limited data. So here mean mu is theoretical thing, then we are calculating average mean, which is given as okay, right? So this thing is estimate of sample, this thing which is known as sample mean, because it is coming out of the sample. So this is sample mean and this is estimate of the population mean. This is estimate, this is not population mean, this is estimate of the population mean, and this is sample mean. This is value of the sample mean, which is estimate of the population mean. Then there is a variance sigma square, and there is a variance we calculate like this. Right? Like this. So sometimes you will put n minus 1, sometimes you will put n. Why, that I will also clarify now in this lecture. You have to wait a bit, okay? But this is estimate of population variance. So far so good. Now we are coming to method of movements. Movements you know, right? I have discussed in much detail. The first and second movements of a distribution give the mean and variance of the random variables, right? These movements are related to the distribution parameters. These movements are related with the distribution parameters. Thus, if a distribution has two parameters, then using the first two movements and their relationship with the distribution parameters, the probability distribution can be plotted. Thus, if a distribution has two parameters can be anything, mu, sigma. Log normal has how many parameters? How many? 2. Normal has 2. Exponential 1. Exponential 1. Beta 2. Right? So some distributions are two parameter distributions, some distributions are single parameter distributions like exponential, and some of you will find, if you go dig more deep, maybe 3 parameter distributions. So it depends. So now specifically here we talk about 2 parameters. So if you have only 2 parameters in your distribution, which will be the 99.99% cases in civil engineering, then only first, see, 2 unknowns, 2 equations. One equation will come from movement, first movement, and then second movement. It will tell you the information about those 2 parameters. Sometimes the movements will not give you the direct parameters, but the first 2 movements will be functions of those parameters. For example, you take the case of log normal distribution. Log normal distribution, the sample mean, sample standard deviation will not directly give you the lambda and zeta. There is some exponential relation is there, and that gives you. So that can be a possibility. But using the movement method, you can estimate the parameters. Note that the samples drawn from the population are also random. इस पे मैं बाद में जाऊंगा, इससे पहले थोड़ा सा मैथ्स करेंगे हम लोग। ये वाला पॉइंट बताने से पहले मुझे थोड़ा सा आई हैव टू डिस्कस समथिंग। So let us say there is a sample size of n samples, right? So sample values are x1, x2, xn. Okay. What is sample mean? Sample variance. So here we don't write mu or sigma, we write x bar and s square. to differentiate between sample and population. Okay. So mu is point estimate, mu population mean, point estimate is x bar, and sigma, point estimate of sigma is s. Note that the samples drawn from the population are also random. So there is a big population. I am writing like this just to demonstrate that population is like everything inside it. But we cannot consider everything. We can take only sample. So there can be infinitely many ways to collect the finite samples, right? If this is infinite, suppose if there is a population of 100 and you want to do the survey on 10. So how many ways are there to get those 10? C10, right? It means, and you are selecting randomly, so that's what it is saying, that samples drawn from the population are also random. Okay, and therefore the point estimates of the distribution parameters are also random variables. Now this is very important to understand. This mu is coming from the population, so this is not random. This is not random. This is from the population. But this is a random variable because this is coming from the randomly selected sample. So if you select 10 samples, if you select 10 samples, if you select 10 samples, you select 10 samples, I select 10 samples, they select, all will give different values of the mean estimate, right? It means that sample mean and sample variance are random variables. If sample mean, if there is a random variable, it has to have a PDF or PMF. Because it is not deterministic. If something is not deterministic, it has to be probabilistically represented, and the only possibility is either you use PDF or PMF, right? Point estimates of the distribution parameters are also random variables and will have their own distribution. This is very important thing to understand. It may look very simple thing, but it has very profound implications. Now we talk about sampling distributions, but before that, let me discuss something about the. I think I missed. Okay. This is the same thing. So what is the expected value of the sample mean? So you know the sample mean. Now calculate the expected value, because sample mean is a random variable. It will have an expected value. Calculate the expected value of the sample mean. Siva, can you help me? There is a very thick layer. Can you just, okay, please. Thank you. So, what is the sample mean? I want to see. Good. E kahan gaya? E kothay gach? आगे तो बढ़ाओ।
लेकिन अगर इसमें उनको एक्सपेक्टेड वैल्यू निकाला तो फिर बात तो वहीं आ गई ना कि डिस्ट्रीब्यूशन कौन सा है।
कोशिश करो ऐसे करो, डिस्ट्रीब्यूशन करो तो सोचो, थोड़ा सोचो। दिखाओ, तुम दिखाओ. Okay. What we want to calculate? This is okay. Okay. Xi is coming from where? Xi is coming from where? Population से आ रहा है. Population से आ रहा है. Xi is coming from population. Here, this is population mean. Mu and so whatever the distribution of population, based on that it will give a mu value. And how this mu will come? Right? So what you were saying was correct, but you were thinking directly about this step.
सैंपल मीन के एक्सपेरिमेंट की बात कर रहे हैं, तो मतलब जब मुझे पर्टिकुलर बहुत ही गलत सोच रहा हूँ, पर मेरे दिमाग में ये आ रहा है कि हमको कुछ फाइनाइट चाहिए ना, फाइनाइट सेट चाहिए ना, हम इंटीग्रेट कर रहे हैं, मैं भी उतना इंटीग्रेट करूँगा, तो इनफाइनाइट सेट इंटीग्रेट कर रहे हैं, सैंपल मीन कर रहा है.
This is for population.
Yes.
सैंपल यहाँ छूट गया इसके बाद.
अच्छा हाँ.
So expected value of the sample mean is equal to the population mean. Expected value, not, but don't get confused. This is not equal to mu. This is not equal to mu. Don't get confused. This is mu. Why? Because this is random variable. That is why this formula is known as unbiased estimator. There is no bias, unbiased estimator of the population mean. Yes, it is not biased. Why? Because its distribution will be like that. That mean will be what is the value at the mean? Mu. That's what we calculated, right? And this is the distribution of what? Sample mean. Sample mean. You are really brainy. Okay, this is sample mean. Okay, suppose one new mathematician came and he gave this, that this is I don't like this thing, I want to make a new definition of mean, let's say n-1 here. Okay, what will be the value of, for that mathematician, what will be the expected value of sample mean? N by mu, which is not equal to mu if n is small. If n is small, but suppose if n is 10,000, it will reach, right? But still, if n is 5, then it means his estimate is biased. His estimate is biased. Which side? higher side or lower side? Because this will be greater than 1. So his distribution will be something like this is known as biased estimator. Idea is getting clear, right? So ये डिफिनीशन आज तक तुमने कभी सोचा होगा ही नहीं कि मीन एवरेज ऐसे ही क्यों डिफाइन होता है. कभी सोचा क्यों हम n से डिवाइड कर रहे हैं यार, क्या जरूरत है? n स्क्वायर से कर लो, n का तो कोई डायमेंशन भी नहीं है. कोई कहेगा डायमेंशन क्यों, n का डायमेंशन ही नहीं है, देयर इज नो डायमेंशन ऑफ n. व्हाई डोंट यू डिवाइड व्हेन यू कैलकुलेट द मीन, व्हाई यू डिवाइड ओनली बाय n, व्हाई नॉट n स्क्वायर? दिस इज द आंसर. Because everything else in this world is going to be a biased estimation of the arithmetic mean. That's why it has been defined like that. This looks very simple, but the answer is very profound. Okay. What is the variance of the sample mean? Now calculate the variance of the sample mean. Please. सी वेरिएंस कैसे कैलकुलेट करते हैं? हाँ ठीक ठीक, यू आर ऑन द राइट पाथ. When did you come? I did not see you. When did you come? When did you put here this duster? I did not see you. I was thinking whether you went also or not. थोड़ा कठिन है ये, लेकिन मुझे लगता है कि some of you may do it. थोड़ा सा कठिन है. ओके चलो हिंट देते हैं. सबसे पहले वेरिएंस एक्स इज पी ऑफ माइनस, ओके. नाउ कैलकुलेट वेरिएंस ऑफ ए एक्स फर्स्ट. Calculate and tell me. How many of you agree with this one? Please raise your hands. Okay, Shraddha? Shraddha? You don't agree? Put the ax here. A will come out. निकलेगा नहीं. छोटी सी चौक है. अच्छा ये है तो सॉरी मुझे लगा तुम कह रहे हो पीछे, मतलब पीछे गिर गया है चौक. थैंक यू. ओके श्रद्धा, क्लियर नाउ? नाउ कैलकुलेट वेरिएंस ऑफ एक्स प्लस वाई. अब ये करके बताओ x is a random variable, y is also a random variable. Here a was not random, a was constant. Now x is random, y is random. Please tell me this one. अब ये करके दिखाओ. ना ना नो 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 रटा हुआ नहीं आंसर चाहिए. टू दिस ना. यू आर ऑन द राइट पाथ.
वैसे अगर इंट्यूटिवली सोचे तो अगर हर टर्म में एक टर्म हम ऐड करते हैं तो वेरिएंस तो जीरो हुआ ना पूरे सिस्टम में ही. मान लीजिए कि हम अच्छा नहीं ये दोनों वेरिएबल सॉरी
रैंडम वेरिएबल
मैं कांस्टेंट
ना 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 कांस्टेंट. बोथ आर रैंडम वेरिएबल्स. कैन एनीवन टेल द आंसर? इफ एनीवन गॉट प्लीज टेल मी द आंसर. अरे ऐसे मुंडी हिलाने से नहीं होगा. यू हैव टू पुट हेयर राइट. So now this time and this time. Yes. This time and this time. This time and this time.
Variance of x, y. Twice.
Okay. Okay. Now, if x and y are two random variables which are statistically independent, then this part cancels out because exy will be ex into ey. This cancels out. This one comes variance of x plus y is variance of x plus variance of y. So what you were writing was correct, but you were writing based on memory. I asked you correct. Okay. So you may get correct answer by wrong approach also, but in future the lack of understanding will lead to always a wrong answer. Okay. So now calculate variance of sample B. बड़ा आसान है. बड़ा आसान है निकालना.
No sir, suddenly 2 points within 15 minutes it dropped the battery.
Battery? Maybe it was not charged.
No, yesterday I charged it for 1.5 hours sir after that.
So it's not working.
Just now it stopped sir. So it recorded up to 40 minutes.
And this speaker it is recording.
No sir, this one I.
Add to the mobile phone.
No, this tripod not supposed.
Maybe it was not fully charged.
Yesterday at the time Tushar sir gave it already 2 points fully charged sir, and I again charged it for 1.5 hour, but it dropped very quickly.
Because now so many things are being used, right? Receiver, transmitter.
Okay. Maybe I will charge for 3 to 4 hours.
100%.
Yes sir, I checked yesterday already before coming here.
So who will tell me the variance of sample B? So variance of xi is sigma square. Use that.
2 sigma square upon n square minus b whole square.
इसको गड़बड़ आ जाएगा. See, it was very simple, now straightforward. After this much discussion,
मतलब माइनस म्यू से मतलब गड़बड़ है.
that I don't know. See, I don't know what mistake you made, but I can show you. Let us say this is 10.
Okay.
No, not let us say, because it is infinite. Right? Because all of them are statistically independent. Why? Because what sample she is drawing has to do nothing with what sample she is going to draw. Right? Statistically independent. If it's statistically independent, then n is constant, 1 by n square, summation. I will go to variance of xi. Variance of xi is sigma square. So n sigma square.
n cancel sigma square by n.
Because sigma square plus sigma square plus sigma square.
N times.
Sigma square. N sigma square.
n cancel.
Yes.
This is okay. This is okay. This is okay.
Variance of a అంటే 1 by square n square అయిపోద్ది. So sigma is equal to 1 by variance of xi.
They are statistically
That's
independent.
equal
Then this is okay.
variance of xi అంటే
Then this
variance
is
of
okay.
xi is
Then this
equal
is
to
okay.
sigma
Then this is
square.
okay.
So then it is equal to 1 by n square. Sigma I is equal to 1 by n sigma
So standard deviation of sample mean. Standard deviation of sample mean is sigma by. And what is this? Sample error. Epistemic uncertainty. Right? Right, Shashan? Okay. Sigma by unit. So in the lecture 1, I gave this expression. Today I gave after almost 1.5 months I gave the proof. So now you can understand the language. Sorry. So this is the variance of sample mean. Now, what is the expected value of the sample variance? Now, calculate the expected value of the sample variance. Please do that. आपको मेरे ख्याल से जल्दी होना चाहिए. Sample variance क्या होगी? First, what sample variance you are going to take? Divide by n or divide by n minus 1? N na? Very good. First, take divide by n and calculate the expected value. लेकिन थोड़ा जल्दी करो यार, थोड़ा ना पता नहीं क्यों स्लो हो गया, थोड़ा तेज कर दिया. तो फिर मैं सीधे सीधे आंसर लिखने लगूंगा, आपको प्रॉब्लम की जल्दी जल्दी पढ़ा. how can you apply directly on sigma? You can apply only on the random variable, which is xi. First you have to write the expression for sigma. Sigma is, right? And then expand it, then apply E on that. I think you understood. That is why you got the right marks. प्रतीक को नहीं उसमें राइट हो जाता है भाई ये सिग्मा का एक क्वेश्चन है तो किसका काम है देखो अब एक्सपेक्टेड वैल्यू ऑफ द सैंपल वैल्यूज एंड यू आर कैलकुलेटिंग द सैंपल मीन वैल्यूज सैंपल वैल्यूज इधर देखो सैंपल वैल्यूज सैंपल का वैल्यूज ये आंखें, ये कान, ये ज्ञान सोचने के लिए दी है। लेकिन इससे कुछ लोग लापरवाही में बर्बाद करते हैं। ये आपको काफी बीमार करने के लिए पर्याप्त है। What answer you got?
N by n minus 1 root sigma.
No, why it is root sigma? It is sigma square. No? Because you are thinking, right. लिखो. Yes, excellent. Correct. Just go on the board and just please write this solution. You got the right answer. If you want to take your notebook, you can take.
सिग्मा मैंने यूज कर रहा है
No, no, I don't. Be fast, just write whatever something you want to know. Summation आ गया summation हाँ डाउन ओके इट केम आउट good. So but okay but you put n here हाँ you got what what did you get
Expected value of sample variance.
If I put it
Population.
sigma square
sigma square
what
what will you take sample variance how will you calculate sample variance first time
Sigma square.
no that same station was no you are getting the right answer by wrong
I also think sigma square should be
of course
Sigma, if I take n, n will be cancelled down. Sigma square will be better. If I take n minus 2,
you told me that you are going to take this one right you told me that you are going to take this one
be sigma square.
then it should become sigma square.
Yes.
Eh? So it is this definition is the non-biased method.
Yes.
Are you sure?
Variance is there.
And what is this? What you have taken as this one as? Is this correct? Let us see. I will simply write now as a square 1 by 8.
Sir, date.
Eh? Got it?
It has to be expected now, sir.
You got it right?
Yes.
Okay. What is the calculate?
Expected or less.
Okay. What is this? This area, right?
That we have calculated already. That is the E of this. Eventually, that should come out to be 2 sigma square.
What is this? This one, if we do like this.
Variance.
This is equal to
Variance of
Plus V square.
okay. So E of x is equal to this. And what is this?
variance.
This is what E of x is?
Mu square.
Mu square.
Mu square is that.
Mu square plus variance of x is? Variance of x is
Sigma square.
sigma square.
Square. Yes.
Put this there. Okay. You have to now put here. Okay. Now this one. How can you calculate this one? Use the same approach. Use the same approach.
E of
Time हो गया, time हो गया.
नहीं सर लास्ट के लैब में
You know, when you time हो गया.
टाइम तो हो गया 55 हो गया सर
250. You want to be?
लैब
Okay. So calculate this one using this various thing. Try it yourself, okay? And we will discuss in the next class. Okay. But my suggestion is to go by speed or how you have this as well. या तो एक्स्ट्रा क्लास में लेना शुरू करो लेकिन स्पीड बढ़ा है स्पीड बढ़ा थोड़ा स्पीड मतलब कि मैं स्पीड इसलिए बढ़ा रहा हूँ कि उसको समझ में आएगा कोर्स करने में मजा नहीं आता है सबको समझ में आना चाहिए see let me increase your speed for I have to take extra class I don't want to increase my speed because then you will say this is not something else